What if you could travel forever? Imagine stepping aboard a starship, pointing it in a single direction, and accelerating relentlessly, pushing the very limits of physics. You have all the time in the world, an infinite lifespan to complete your journey, your mission to find the edge of the universe. How long would it take? What would you see when you got there? A wall, an endless void, or something so strange it would shatter your understanding of reality? These are not just questions. For science fiction, they are some of the most profound mysteries that haunt cosmologists today, that if you enjoy exploring the biggest questions in the cosmos, then join us on this journey by subscribing to our channel. We dive deep into the wonders and terrors of our universe, and by subscribing, you ensure you won't miss a single mind-expanding adventure. Now let's begin our voyage to the ultimate boundary. Our quest begins with a modern-day puzzle. Our most powerful eyes in the sky, the James Webb Space Telescope, have peered back into the dawn of time and found impossibilities. Ancient colossal galaxies far more massive than they have any right to be existing in the universe's infancy. Our current models of cosmology, the story we tell ourselves about how everything began, insist that there simply wasn't enough time or matter for these giants to form so quickly. This discovery whispers a terrifying possibility that our entire timeline is wrong, that the universe isn't 13.8 billion years old, but perhaps much, much older. If our fundamental understanding of the universe's age is in question, what else are we wrong about? This uncertainty is the perfect backdrop for our journey. If the universe has boundaries, we must first understand the limits of our own perception. When we look up at the night sky, we are not seeing the present. We are looking into a museum of the past. The light from the moon is a second old. The light from the nearest star, Proxima Centauri, is over 4 years old. The Andromeda Galaxy appears to us as it was 2 and 12 million years in the past. So the farthest we can see is not a physical wall, but a time wall. The cosmic microwave background radiation, a faint afterglow from the Big Bang. This is the boundary of our observable universe, a bubble roughly 93 billion light-years in diameter. But this is just the edge of our vision, not the edge of reality. What lies beyond? To find out, we can't just look. We have to go dot. Let's return to our starship. To make the journey comfortable, it accelerates constantly at 1 g, or about 10 man-penton squared. This provides the crew with a perfect simulation of Earth's gravity. For the first few days, the acceleration is thrilling. You'd pass the orbit of Neptune in under 2 weeks. After a year, you would be traveling at a significant fraction of the speed of light. But here, Einstein's laws of relativity take over, and reality begins to warp. You can never quite reach the speed of light. It is the ultimate cosmic speed limit. As you pour more and more energy into accelerating, you get infinitely closer to that speed, but never touch it. From the perspective of an impossibly observer back on Earth, your ship would appear to slow down its acceleration, your clocks ticking ever more slowly. But for you on board, the acceleration would feel constant. Time would feel normal. It is the universe outside your ship that would seem to be speeding up. Centuries on Earth flashing by for every year you experience. Particles have been observed moving so close to the speed of light that for them a journey across millions of light years would feel like mere minutes. Time itself almost stops at light speed. For our crew, this time dilation allows them to cover immense cosmic distances within their own lifetimes. After just 2 decades of their own subjective time, they would have traveled far enough to reach the Andromeda Galaxy, but their journey is far from over. They are heading for the true edge, and this is where things get truly strange. There is a point of no return. A line in the cosmos that once crossed, you can never cross back. This boundary isn't made of rock or energy. It's woven from the fabric of space-time itself. The universe is expanding, and this expansion accelerates. It's like trying to swim up a river whose current is getting faster the farther you go close to home. You can easily swim back to the shore, but venture too far, and you'll reach a point where the river's current is faster than you can possibly swim. No matter how much energy you exert, the current will carry you farther away. I in our universe. This point of no return is about 15 billion light years from Earth. Any galaxy or any starship that crosses this threshold is carried away from us by the expansion of space faster than the speed of light. Yes, you heard that right. Not the ship moving through space, but space itself is stretching and carrying the ship away. From that moment on, no message, no light, no signal of any kind can ever make it back to Earth. You are causally disconnected. You are, for all intents and purposes, in a different universe. The crew presses on. The galaxies they see begin to change. They are seeing the farewell photos of the cosmos. Over 95% of the galaxies we can see in our sky even today are already beyond this point of no return. We see their ancient light, a ghost on a cosmic photograph. But the light they are emitting right now will never reach us. They have vanished from our future. As our ship travels on, every star and galaxy it passes is another farewell. The sky ahead grows darker, and the sky behind the view of home eventually fades into nothing. So, does the journey end in an empty dark void? Perhaps. But what if the universe is tricking us? What if it has an edge, but not in the way we think? For millennia, we assumed the universe had to be either a finite box or an infinite expanse. But there is a third option, one our minds struggle to grasp. The universe could be finite, yet have no edge. Think about the surface of the Earth. It's a two-dimensional surface. You can travel in any direction, and you will never find an edge. You won't fall off. But the surface of the Earth is clearly not infinite. You will simply end up back where you started. Now imagine this same principle applied to our three-dimensional space. Our universe could be curved back on itself in a fourth spatial dimension. If you traveled in a straight line for long enough, you wouldn't hit a wall. You'd simply arrive back at Earth from the opposite direction. Scientists have tried to measure this universal curvature. Back in the 19th century, the mathematician Carl Friedrich Gauss secretly measured the angles of a massive triangle between three mountaintops, hoping to see if they added up to more or less than 180 degrees, which would prove that space itself was curved. His instruments weren't precise enough, but today we can do the same test using the light from the early universe. The result, as far as we can tell, the universe is perfectly flat. The angles of the largest triangles we can measure add up to 108 degrees. This flatness points towards a universe that is truly mind-bogglingly infinite. And an infinite universe is far more terrifying than a finite one. If space goes on forever, then every possible configuration of particles must exist somewhere. It means that an infinite distance away from you, there is another Earth, with another version of you living a life almost identical to yours, and an infinite number of other versions living out every possible choice you ever could have made. The horror of infinity goes deeper. In an infinite space with infinite time, even the impossible becomes inevitable. Due to random quantum fluctuations, particles can pop in and out of existence from the vacuum of empty space. The probability of a complex object, say a piano, spontaneously assembling itself from these fluctuations is astronomically small, but it is not zero. In a finite universe, it would never happen. But in an infinite one, it is guaranteed to happen. In fact, it is guaranteed to happen an infinite number of times. An infinite universe is a place where everything that can happen will happen over and over again. But there is a final twist. Perhaps we've been asking the wrong question all along. We ask, where is the edge of the universe? Assuming it's a place we have to travel to. What if the edge is not a distant location, but a direction we cannot perceive? Imagine you are a two-dimensional being living on a perfectly flat sheet of paper. Your entire universe is that sheet. You can move forward, backward, left and right, but you have no concept of up or down. Now imagine I, a three-dimensional being, look down upon your paper universe. I can see everything in your world at once. I can see inside your houses, inside your bodies. For me, the edge of your universe is right there, just a millimeter above and below your entire existence. The third dimension, which is everywhere for me, is a completely inaccessible, invisible boundary for you. What if our three-dimensional universe is like that sheet of paper existing within a higher four-dimensional space? If so, then the fourth dimension isn't far away. It is everywhere. It is all around us through us at every single point in space. Just as the third dimension is all around the 2D paper world. The true edge of the universe, the ultimate boundary, might not be billions of light years away at the end of a long journey. It might be right here, right now, an infinite decimal distance away in a direction we are physically incapable of pointing to or moving in. And from that higher dimension, a hypothetical being could be looking down on us, seeing our entire universe from the Big Bang to its final fate, all laid out before them like a map. The edge isn't a destination. It's a perspective we can never have.